So what we're going to look at on this video is independent probabilities and non-mutually exclusive events and how to calculate those probabilities. So let's just look at a set here. Okay, so imagine we have set A and set B. And there's an overlap between the two sets. So these are non-mutually exclusive events because there's an overlap between the two sets. And remember, the rectangle is the universal set. So the universal set is all possibilities are in the universal set. All elements are in the universal set. And A and B are known as subsets of the universal set. It just means that they're inside the universal set. So let's look at this problem here to make sure we can see what's going on here with non-mutually exclusive events. So let's say we have this universal set that has a total area of 1,200 centimeters squared. So that's the total area in that universal set. So universal set doesn't always have to be numbers. It can be areas. It can be objects as well. So, and then there's two sets. I have a set that is a purple rectangle there, and I have another set that is a blue rectangle, and yellow is the overlap. So those two sets, let's call that one A and this one B, are non-mutually exclusive. There's an overlap between the two sets. The purple area has an area of 100 centimeters squared. The B area has 100 centimeters squared as well. Now, the area of that overlap is 25 centimeters squared. So let's look at the question. The next question we're going to say, what is the probability of A being an A or B? So what we need to look at now is the formula basically of a non-mutually exclusive event. So what we have to do is write this formula here. So the probability of A or B, well, that's just it's just the probability of A plus the probability of B minus probability of A and B. That's the overlap. Okay. So for our problem, the probability of being in event A was, let's just do that right here. It's okay, so it's our desired over our total. It's going to shorthand it here. Okay, so, and let's just do B right beside it. So it's the desired, let's write D over T, just desired over total possibilities. So the desired for A was my 100 centimeters, because right, the A has a area of 100, B also has an area of 100, over the total possibilities, which is just my total sample space, which is 1,200 centimeters squared. So 1,200. Okay. B is the same thing. It's 100 over my total sample space of 1,200. Okay. So now what we have to do is subtract out the overlap. So remember, this one was A plus the probability of B minus the overlap. And if we look at the overlap here, it's 25 out of 1,200. Okay, so when we do that calculation, we will get 7 over 48 when we simplify it. So that probability would be 7 out of 48.